All right, now here's where the problem comes in with correlation. We cannot say that changing one variable causes a change in the other variable. We can say that there's a relationship, there's a strong positive relationship or a strong negative relationship, but we cannot say that the change of one affected the change in the other simply because there's something else, such as a third variable, which could be causing the two things to relate. So we can only make these statements after we consider what type of variables are we really looking at. So we need to have some type of a logical basis to be able to state for certain that we know why these two things are impacting. Again, you go back to that idea of the number of civil engineering PhDs is highly correlated to the amount of cheese eaten. There's no logical basis there, therefore we cannot make any casual statements regarding the nature of those variables involved. Another helpful is bivariate and partial correlation. Bivariate correlation is simply the correlation between two variables. You can use either Pearson's or Spearman's. And partial correlation is taking an effect of that third variable or third and fourth variable. So we're looking at the correlation between two variables but holding that third or fourth variable and controlling for it. More on this. All right, partial correlation, we talked about that. And semi-partial correlation, measuring the relationship between two variables, controlling for the third variable, only that third variable has on one of the others. And this is very useful, more so when we get to regression, because we're trying to explain the variance on one of those variables from a given set of other variables, such as predictor variables. So an example is, if you're taking an exam, the amount of anxiety you have in taking that exam are correlated. You know, if you're very anxious, you may do poorly on the exam. If you're very anxious, you may do very well on the exam. You know, it depends upon your personal approach. But the amount of time or revision, you know, you go back and get to review your exam. If you have time to review your exam, your anxiety will probably go down, which means your exam score would be better. So that's an idea of partial correlation. That third variable, revision, or able to revise your exam or review your exam, would have an impact on the exam score itself, in addition to the anxiety that you feel. Semi-partial correlation is, we won't tie reviewing your exam to anxiety. We just want to look at the reviewing the exam and the score on your exam. Now, if you have the time to go back and look over your exam, we would expect that you would have a better exam grade because you're able to review and maybe find your errors that you had when you were going through the exam initially. So if we look at that, these are just some examples given that correlation elements. But we have exam performance. So this is the data set for exam performance, and this is the data set for exam anxiety. So we have an overlap that anxiety impacts performance. And we can say, well, the variance that's accounted for by exam anxiety is 19.4%. That's how much your exam performance is impacted by your anxiety. If you look at exam performance and your ability to revise your exam, now that variance accounted for is 15.7%. So you put all three of those together, we have a piece of the variance that's unique to being able to revise your exam, a piece that's unique to be able to understand the anxiety associated with the exam. But then there's the combination of, if you were anxious and making mistakes but had time to go back and revise it, your exam performance might be different. And so that's the variance explained by both of those conditions. So we're going to go ahead and look at how to do this. We're going to look at anxiety and exam performance, 103 students, the measures, time spent completing, the exam performance itself, exam anxiety, and then the gender of the individuals. Now this slide is blank because I would like you to maybe pause the slideshow here and go back to the piece where we're going to be looking at how to do correlation on SPSS, or you can continue, but keep in mind that there's a piece of the SPSS correlation. I'm showing you how to do it on SPSS 22. You can stop and look at that before we look at the results that we received just by running that correlation. Correlation is nice, and the idea that it's really basic output. So we have exam performance that was measured with this Pearson correlation. We have an exam performance correlation with exam performance of 1.00, and hopefully they would be perfectly correlated, just like exam anxiety, and exam anxiety is perfectly correlated, and time spent revising is perfectly correlated with itself. So each variable should be perfectly correlated with itself. Now we can look at exam performance in comparison to exam anxiety. It is negatively related to exam performance. So it is a negative 0.441. That double asterisk means it's significant at the 0.01 level. That's the 99th percentile level. We generally like to look at 0.05. So obviously if it's significant there, it's significant at 0.05 as well. And that significance one-tailed. If it's less than 0.05, which it is, it's significant at the 95th percentile. So we have a negative correlation. As exam anxiety increases, exam performance decreases, which does make sense. So there's that logical piece added to that. Exam performance is also positively related to time spent revising or reviewing your exam. So the more time you spend reviewing your exam, you will end up with a higher exam score. So again, these aren't great correlations, the 0.4 and the 0.3, but they do fall in that category of low correlation, but they are correlated at the 95th percentile level, both of them. And then exam anxiety is negatively correlated with time spent revising. So the more time you have to review your exam anxiety decreases, which again makes sense. And that's also significant at the 0.05 or 95th% level of confidence. Now what we can do is we can take that coefficient of determination, and if we say 0.441 squared, right, take this 0.441 and square that to get our coefficient of determination. Exam anxiety, we can say, shares 19.4% of the variability in exam performance. And then the remainder of that, 100 minus 19.4, would lead us with 80.6% is in other variables. And we could do the same thing for time spent revising, 0.397 squared. 15.7% of the variability in exam performance is related to time spent revising or reviewing your exam. So that's nice and interesting information. Here, this is just repeating exactly what I had just talked about. Everything should be perfectly correlated. Performance negative related to anxiety. Performance positive related to time spent. anxiety, negative related to time spent, and at 19.4%. Again, that's just squaring the Pearson correlation to determine that coefficient of determination. That's all that is. It's another example. So here's the world's best liar. We had 68 contestants, and I do have to tell you that I'm using some of the examples and the homework. I know that this is somewhat boring material, so we've got hopefully some interesting examples for you, or interesting homework that you'll at least get a chuckle out of. I don't want to completely overload you with just engineering examples, because you would all probably fall asleep within 2 minutes if you haven't already. All right, so the world's best liar competition. Where they placed in the competition, first, second, third, or etc., based upon their creativity questionnaire, so they had a score of 60 for that. All right, so here's our output. Here we did Spearman's row and Kendall's tau because it was ranked data, right? First, second, or third. It was not interval data. And we still see creativity is perfectly correlated with itself. Position is perfectly correlated with itself in both areas. And we also see that there is a significant relationship between creativity and the position. And it says it's a negative relationship. So as creativity increases, the position decreases. Now this is where this piece of logic comes in. You would assume that as you become more creative in your lying, the position that you would have would become greater. Well, that is true because the position, first place, is the best place. So as your creativity score increases, you lower your position in the best liar competition, which means that is the correct relationship. You should have a negative relationship. You should score lowest for being the best creative person because that would mean you had the best lie. I believe that is what that says there. However, we can't assume, right, that creativity caused the success in the best liar competition. It could be something else associated with it. Maybe the person is a sociopath that has major problems. So that's, again, one of the problems with correlation. Look at some partial correlation. Again, go ahead to your SPSS correlation video. There'll be more information here. And then here's the output for that partial correlation. Here, we want to look at the first piece, this first part up here. We have no control variable, so this is what we had done before, and those numbers are exactly the same. But now we want to hold the time spent revising or reviewing the exam. Going to control for that and look at exam performance and exam anxiety. So the partial correlation between performance and anxiety is a negative 0.247. So before it was negative 0.441. So we've reduced that correlation by controlling time. The relationship, it is still significant because it's 0.006, which is less than 0.05, but it certainly has diminished from before. So that's interesting, so that we know that time spent revising does play an impact on anxiety. So if you take that 0.247 and you square it, you end up with 0.06. So that means you have exam anxiety accounts for 6% of the variance in exam performance. And if you remember previously, we said that exam anxiety accounted for 19.4% variability in exam performance. So now, because we're controlling for that third variable of the time able to spend revising the exam, we're able to hone in on really exam anxiety itself. So that's that unique variance associated with exam anxiety. Correlation that we're really not going to get to too much, and we're going to find out why. Serial and point by serial correlations, generally used when we have a dichotomous variable. It is dichotomous, it's categorical, but there's only two categories, and there's no underlying continuum between the categories, which means, a good example is you're either pregnant or not. You cannot be partway pregnant. You're either pregnant or you're not pregnant. So it is a discrete categorical variable. Another good example of categorical is that has a continuum. You could pass or fail an exam, but you can fail it by a larger margin, and you can pass it by a larger margin. So there's a continuum that exists between those categories. The biserial and the point biserial is really specifically used for that discrete dichotomy. So either pregnant or not, married or not, or whatever other example you want to have. So how do you do this? The biserial correlation is designated with an RB for correlation biserial, and the point biserial is just a correlation PB, but point biserial. Unfortunately, you can't compute these in SPSS, so you first have to start out with calculating your correlation and using the formula as such. So a little bit, we usually don't do too many of the biserial and the point biserial, and I doubt you would have for your research as well. But if you did, for the correlation coefficient, you either have to have 0 for one category coded and 1 for the other category coded, or it will not work. And then the size of that correlation depends directly on how that dichotomous data was coded. So obviously when the data is recoded, the sign changes, which means the direction of your relationship will change. So we can't really go with the negative or positive relationships. We can only go with strong or weak relationships. So that's a huge point biserial correlation. And then the biserial correlation significance, whether you find out whether or not it is significant, since we can't run this through SPSS, you would have to calculate the standard error, create a z-score, and then look that z-score up in the normal table to figure out whether it is significant or not at that 95th percentile range. But again, we're really not going to be focusing on the biserial or the point biserial. We're really going to be focusing on the bivariate, the partial correlation, and the semi-partial correlation. So this time you're free to move ahead. Don't forget to take the reading quiz, which if you wrote down every element from the lecture show here, you should get 100% in that reading quiz, and then look at a review homework that's posted, as well as homework number 1 covering this topic. Thank you.